reverse engineering protocols, followed by ASCII art for beginners. So it's all yours.
So, alrighty, hey everybody, welcome to my talk. I am netspooky, and I'm here to give some talks about reverse engineering unknown protocols and ASCII art for beginners. So, I spoke at last con. It was really awesome. Big thank you to Leslie and everybody who's doing this. This has been awesome to watch. All the talks have been great. And so, yeah, if anybody here has any questions too, I'll have a Q&A at the end. Hopefully, if you have anything, or if not, you can always hit me up on Twitter. So, okay, let's get started. So first, who am I? Simple, I'm netspooky. Our website is no.lol or n0.lol. We'll just get right into it because I don't have too much time. I have a lot of content to fit into this here thing. So reverse engineering unknown protocols. This is kind of like the staging bit for it. So, you know, it's hard to sometimes understand why you would want to do something like this. So basically, has this ever happened to you? Peering into the void. So if you're seeing any strange requests in your logs, or you notice something that doesn't really look right in Wireshark, or you have some devices that are speaking in some strange language, or some software talking to a server in a binary protocol, maybe some malware even, you might search online, just look up ports and different elements of the message, and you don't find anything, or you might find something, but it doesn't really seem to match up with what you're seeing, and you start to feel a little bit unnerved. So a lot of people, when they come across the situation, might feel like they can't really do anything about it, and so they just kind of give up, or they don't really have time for it. But today, after this talk, hopefully you will be a bit more apt to actually want to go in and investigate these kind of protocols. So when you're looking at a protocol, you got to ask yourself, like, what are you looking at here? So for me, I do protocol reversing professionally, and hold on one moment. I had to do a lot of sort of like research and just study into this field to kind of put it into something that is, like, I guess, able to be shared with all other people as well too. So I do a lot of things with classifying languages or protocols as languages, and writing dissectors and things. And so kind of some of the things that I really like, the ground truth for it is really that, like, protocols are just like a language where they are meant to make sense to somebody. So you might see like a big mess of binary characters, and you might think, like, I don't know what this could possibly mean, but there's going to be something somewhere that this is meant to make sense to. It might only be meant to make sense to one person, but still it's supposed to make sense to somebody, to a computer, whatever. So there are certain characteristics that are part of every language, and so, like, there's different things like verb order, or like how words are constructed and things like that. And so not every language has every characteristic, but there's like a general sense of how things are going to be naturally designed. And so being aware of them, like, really helps to just understand how something might be structured. And so archaeologists and linguists, people who look up dead languages, things like hieroglyphics, they understood how languages are structured, and so they're able to piece out things based on different analysis techniques and existing linguistic knowledge, to be able to figure out how something would have been written or spoken, even if it hadn't been, anybody had used it in over 1,000 years. And so with this whole thing, there's a lot to it. And so it's really important early on when you're looking at a protocol to establish your goal. So you got to ask yourself, like, what are you looking for here? So you might be just trying to get a basic understanding of traffic so you can classify it. Maybe even put up a firewall rule for, detecting something, or, some sort of like a network monitoring alert. You can also try to decode the traffic into something meaningful. You might be trying to expand the existing knowledge of a previously unknown or proprietary protocol, or you might even be looking to find vulns in the protocol, which is always interesting too. So the first and foremost thing that you got to do with this is collect data. There's some tools for collecting data. Well, collecting data would be through TCP dump or Wireshark. There's other tools that you can use as well. Those are my two main ones. And then you can use Network Miner to also enumerate data from Wireshark or other PCAPs. There's a lot of tools in this, so these are like just my basic go-tos here. But the point is to collect and isolate the traffic that you're trying to find, or more information about. You want to find where the weirdness is in your PCAPs, and really just hone into it and look at it. You want to get a really detailed view of sessions, ports, protocols, things like that, just so you can have like a baseline understanding. I usually, when I'm doing something like this, I'll create a capture filter on something after I notice something. I could try to like find out like, okay, what else is communicating on this port or has this value here. You try to like get a lot of data and try to make it as specific as possible. And so a lot of this is like a Sudoku puzzle, I usually compare it to, where you get some of the data, some of the information, but you have to like lay it out, and you have to put you have to fill in the blanks basically as you're going through the packets here. So hold on one second. So when it comes to, as I said before, with like the different patterns and constructs and language, there's a lot of design patterns that are going to be in protocols. And so people who design protocols, they typically follow a certain, design things that are going to be helpful, not only from a just like a general sensibility perspective, but also for the medium. Like if they only have a certain transfer rate, they might want to use smaller data sizes and smaller packet chunks. Or if they have something that might be noisy, they might want to have a bit more like error correction and things like that. So there's a lot of paradigms. The most common one that you usually see is like around like tag, length, and value. So like a tag would be something like, say, a message type or an opcode. The length is the length of the overall packet or the message itself, and then the value is the actual data you're going to transfer. Usually, a lot of protocols will have a header of some sort. They can contain things like links or checksums or opcodes, routing info. You'll oftentimes find too delimiters and padding. The same thing, reason we have punctuation, so we can add, where certain thoughts and ideas begin and end. You also have support for different data types and fields. There might be ranges within a value, like say like a 1 byte might only be able to be expressed between 0 and 0x10. There's also encapsulation and wrapper protocols that you might have to contend to and use as well, and have some other sub protocols that deal with that kind of stuff. And there's also just endianness too. There's a big endian, which is like network byte order, which is like you'll usually see that with network-based applications. Things will be big endian or little endian, and they can be mixed within the same message. It gets really confusing. So the main thing I guess I want to talk about, and these are like the lexical pieces that we'll pull together for the demo in a second. And so when looking at a protocol, it's really important to keep like the logical elements in mind, because they can help you kind of make sense of what you're looking at here. And so we have like data types and sizes. So these are like the size of fields in a given packet. Like typically you'll see things that are like 1 or 2 or 4 or 8 bytes in length. There's like other variable length ones too, but those are like standardized block sizes. There are also variable, the variable stuff has the length stored before it usually, like in the TAD length value paradigm there. You'll find like sequence numbers and message IDs, and those are used to keep track of the order of messages. Session IDs are used to keep track of individual sessions, so you can usually look for the same value only ever transmitted by one conversation or one host as the session ID. There's authentication data, which is any credentials used to authenticate to the host. Message types are anything that is a specific value associated with the type of data that's within a message. Function codes are commands that are given to a host. They might specify like some operation to be done in the future. They can be anything from a single byte to like a full string or a series of strings with parameters. There's checksums that are used to verify the integrity of data. There can be encryption, which is pretty hard to track sometimes. Well, you can kind of look at there's different ways of verifying that something is actually encrypted or not, but that's just something to be aware of in this too. Unicast and multicast, like anything that's like some messages might be different if they're sent from one device to another versus sent to the whole network of messages. There's chunked data and streams, which are just for like file uploads and real-time data. Examining how that stuff is handled is really useful too. You might be able to like extract entire files from a packet. So following sessions in Wireshark is good. Flags can be some sort of like fluctuating values of like a single bit or more that are within a specified like byte. So usually flags will be on like a 1 or 2 byte kind of thing, and you'll see like a Boolean like either like 1 or 0 on one bit. And then there's also padding as well, which we said before, which can help to like space out certain data types and data fields. And then record counts are the number of records in a message. And 1 second. Perfect. Okay. So the example here I have, just a really quick one, is TLS. This is my favorite write-up, by the way, of any write-up. It's just very well done. It's a traffic analysis of an SSL/TLS session. Real simple over here. This is like the protocol format. So there's like these record type values and then the hex for it. There's versions, and all this sort of stuff is just transmitted within this 5-byte, binary chunk here. And then within there, this is encapsulated this alert layer, which is just 2 bytes that explains, the severity of an alert and then the alert description. So here, this is just like a record or an example here with the record and alert layer that is just saying like a warning that the certificate is bad, or it's it's a bad certificate. And it's actually funny because this 4th-bit website doesn't have an SSL cert, so you kind of get this message too. But this translates directly to something like this, where you have, you see the cert name invalid, right? It's just a bad cert. But this sort of thing here, you can just read through and read the spec and see that there is, the hex value for, what's it called? Hold on 1 second, my computer's really being really weird. Hold on. Okay, sorry about that. So yeah, you can see this the hex message here is in this lookup table here, and this is within the spec itself. So not everything's going to have a spec, but this is just kind of like how these sort of things that I had explained before kind of go and are actually implemented. There's like the record type, and there's like the links and the values and things like that. And so it's really important though to remember that there's, just because something has a spec doesn't mean that the implementations actually follow it. There's a really big battle between like the protocol specs, the hardware and software implementations, and the type of traffic you actually see. And this goes whether or not it's a documented spec with an RFC or it's a proprietary protocol. There could still be errors and things, so not everything can be really set in stone. And that's why it's really important for you as a reverse engineer to look at the way that things are actually happening on the wire. So here's some simple RE techniques. I'm not going to go over them, but you can do things like traffic manipulation, like on the wire, protocol fuzzing, which is a lot of fun. And then you can also RE like the software, the drivers, or the hardware to figure out how protocol stacks are implemented by various components of that speak the protocol. And so the thing we're going to focus on for this demo here is analysis techniques. So there's really basic stuff to just analyze like the different components of a protocol. And so we have things like frequency analysis, which is how often does a value appear at a specific location. We also have length analysis, which is just like how long are the different messages and different sizes and things like that. And then my favorite one is differential analysis, which kind of uses both of these two, which are what are the specific differences between similar looking messages. And so we'll do this demo here with pdiff. And 1 second, let me just pull it up here. Okay. So, forgot. So pdiff is a tool that I wrote earlier this year. There's just a binary protocol differ. And so what this does is it just helps with the differential analysis, which I can demo, but it's github.com/netspooky/pdiff. And so if we're going to be doing this, let me grab my demo one-liners. Well, first we can take a look here at this PCAP, and then we'll use pdiff for it. Sorry about that. So this here is a protocol that's a stock ticker protocol, I think. I don't really know. But I found this PCAP randomly, and it has just random fields in here. Hold on. Like my Wireshark can't dissect it, but I know that there's data here. And so let me just move this over here. So if we're going through, when we're looking at like a PCAP, one of the first things that I usually try to do is just try to see like who's talking to who. And so we see that there's a source and the destination are actually the same. It looks like it's just like a one-way UDP session. And we see things like the lengths here, like length 58, 41, 45, the different sizes of messages. What I typically try to do is just scroll down and try to look at the dump here. So we notice the data is right here. You just scroll down, and this kind of gives you like a better idea of like what is actually, what kind of data you're actually looking at here. And so the payload here, if you notice, the first like 16 bytes seem to be almost exactly the same. That 30, 30, 30, 30, and then all the way down to 1CDE, just all seem to be exactly the same. And then these bytes right here, hold on, like this, can't really select it. These two though are, they seem to be incrementing in some way. So it's like 3dB, 3DC, 3DD, etc. And then there's a lot of stuff that stays the same as well, like all these zeros and stuff. And so what's tough about this is that, like, you know, when you look at something like this as a beginner or somebody who's just getting into it, it can look just overwhelming because it doesn't really like tell you much. There's just like some random like ASCII, and then there's a bunch of just bytes, right? So for a tool like pdiff, what you can do is, let me just clear this real quick. You can run this on this pcap, and what this will do is it will take it'll basically count all the bytes in this data portion. So if you know how we saw that 30, 30, 30 that's like the same, if you look at all 62 bytes in this packet, byte 0 is always 30, and it's actually always the same for those first 16 bytes here, which is good because we just are able to determine that right away. That's what we were able to see with our eyes, but sometimes for really big PCAPs especially, it's hard to, you know, go through and scroll through the entire thing and figure out what it's saying. But so we started to see some more interesting stuff here. We saw that stuff that was incrementing, and we see how they're in order here. These things that are in order are probably like a sequence number or like a message ID of some sort that counts, because if you see here, this one will order it with the first occurrence of it, and then it'll just kind of go in alphabetical order down. So we're seeing here that there is a, you know, what appears to be a sequence number of some sort. And what I do know, because I truncated this pcap, but this also increments as well. So we know that there's at least a 2-byte sequence ID here. And then we see other stuff where there's padding and things like that. But then, hold on one second. We can also go through and look at the other things that are staying the same. Like right here, there's like a 0. So we know that there's always a 0 here. And then there's either a 0 or a 2. This is always the same here as well. There's 37. And then there's, for some reason, a 25 and a 24 as well. And so you can start to see, you know, you're going through this, that there are these certain patterns and delimiters and things like that. We have like a 0 that's a delimiter here, but it also, a 0 next to like one number like this could also mean that the field length is like 2 bytes or something like that. We have stuff like, so kind of go through what I already know about this of having enumerated this, is that we have stuff like this here where there's always a 0 and then there's like a 1 or a 2. And so if we look at, say, hold on. You can do a Wireshark thing for whatever here has 2. And we notice that there are, you know, there's a 2 here, and that's followed by 13, right? And so something that I try to look for in these kind of packets is what is a, what's it called? Like a length of the rest of the packet. And so that sort of stuff here is the length of the rest of the packet is at this field normally. So if we go to, like, say right here, there's 0, 1, and then 0, 2, 4. 2, 4, you notice this is like 1, 0, and then this is also another 1, 0, so this is 20 and then 4. So in hex it's 2, 4. It's like tricky to eyeball, but you kind of just get the hang of it as you look through here and see, you know, certain consistent values, and then you can kind of like calculate, you know, the rest of the packet length and things like that. are always stuff to look out for. And I realized that I'm already almost halfway through this thing. So hold on. So all right, so doing all this stuff here, going through is a really good first step for just establishing the baseline of stuff here. We can see in the PCAP, we know that there's like this sort of long session ID or something right up here, this 0072 or 525B. That's like the session or token or something that might be transmitted, but we know that's always consistent. We know that there's consistent zeros and things like that. I mean, you can use that to establish like a very baseline thing with the protocol spec. So we can see like session ID. We know that some things are unknown, but they're always the same. And when you're trying to go through this, you kind of want to like just space out, different fields that you notice consistencies at, and just throw them into like a little grid. You can put them in an Excel spreadsheet, and then you can use that to build the sectors as well as guide the rest of your stuff. But it's really good to take good notes of all this kind of thing, just so you can know where data is appearing. And so I'm already out of time on this specific talk, and I knew I was going to because I have way too much info for this one. So I might do a class or something like this in the future, or like a presentation. So hit me up if you're more interested in this. This probably wasn't the best way to present it. So one moment while I switch over to the next one. All right, so I should be able to just breeze through this one because I was like realizing halfway through this that I was completely not on time for what I was trying to finish here. So ASCII art for beginners. ASCII art is something that I've been doing for a long time, and I've been wanting to share more info about it with people, just because people ask me all the time like how I do things. And so I kind of wanted to do a quick overview of like what is actually available in terms of ASCII art to like what kind of styles and tools and things. And so you might have seen stuff I've done before. Here's like a fake DNS server for a CTF that was returning ASCII art of Gucci Mane and some text records from DNS. But stuff like this, there's a lot of ways to liven up the things that you do. And so I tend to just add ASCII art to everything and just see, if people appreciate it. So, all right, let's go into some styles real quick. So it's basically like different styles of ASCII art. This line-based style is kind of a bit more common in like older ASCII art. There's a lot of examples here. So most of the examples in this I made myself, but most of them on this page I did not. Like this Tor one down here, or the goose that Gilda put into my Metasploit, or this cityscape that Zero made. So we have the line-based, line-shaped characters that are used to create like a bigger structure. So this is a style that I usually like to just kind of experiment with. There's a lot of really cool fonts for it. There's also solid and shaded. So you'll see a lot of this kind of stuff in like an ASCII art generator. So you'll see in here, like these are kind of like rough approximations of stuff that are used with the actual letters to do like the shading portions of it. ANSI art is there's too much to cover in ANSI art, so I'm just gonna like leave it to you to go to 16 colors and look at some of the history of ANSI art. But it's basically using block elements and ANSI colors to create terminal art. And so one of my favorites one is this DEF CON one that my friend Zero made that has like a QR code written in ANSI. It's so cool. But yeah, these are done with like block elements that you might have seen in Twitter and stuff too, or in other ANSI art. But they're a lot of fun. Calmoji I really like too. This is like the Japanese style of like emoticon. So you'll see like a kind of like a line-based stuff, but they use like a large Unicode char set to really like make stuff happen. So if you can see, there's my favorite Twitter is twit_bot. It's they just tweet out constantly all this kind of stuff, and it's amazing. It's very, very expressive because they use pretty much everything in Unicode, but it can also fit into small spaces like tweets. So you might have seen a lot of this stuff people posting variations of it. They're really popular, and there's actually a really sick repository. My favorite like collection, I guess, of Calmoji is the CIA Vault 7 leak, which for some reason just has this Japanese style faces page, I guess for talking to people on Japanese chats. But they have like some of the best Calmojis, so you can use those as a starting point if you want to play with them. Things with unique char sets are a lot of fun to play with too. So early computers had their own char sets with unique glyphs in them for expressing parts of the UI and stuff like that. PetSki is a really good example of that, Commodore PetSki. Amiga fonts were also really well known for unique spacing and characters. And then this font Unski I really like because it tries to mimic some custom char sets here by adding like random stuff like triangles and portions of triangles, so you can do interesting effects like this here. So tools are really important. So ASCII art generators, these are things that there's quite a few of them, so I kind of want to just go over them. Generators can make design decisions for you and make it a lot easier to do ASCII art designs, but the decisions can be flawed and the outcomes can be really weird. They often need a lot of space to make an image look right, just because images now are pretty high resolution and they have a pretty hard time expressing small shapes. Image artifacts can also cause like rendering issues too. So if you have like say like just a random block of stuff that's just a little bit shaded differently from the background due to compression or something, that can just add randomly some different block that's generated in the generator. So manual cleanup can make the output a lot smoother, and also just using it for small shapes too is pretty okay, but it's definitely tricky. Some examples of ASCII art generated stuff is this. So I have like this bot eye, looks like an anime girl, and then DJ Khaled's head with another one. So editors are really important too. I use Sublime Text 3 for most of my stuff because I can do regex, I can do column select, which if you do shift and right click in Sublime Text, you can do a column select and select and replace things like that. You can do configurable line spacing, and it's really nice for just doing layouts and things like that. Moebius is an ANSI editor that's I use pretty much exclusively now for my ANSI art. Older ones are Pablo Draw, which is also really cool. There's a lot of features in there as well. And then there's PetMate for PetSki if you're interested in that too. So here's an example of using Moebius to draw some VX Underground fan art. This is the Slayer logo with VX Underground. But yeah, so here's a general interface. You can kind of just draw. It's almost like a Microsoft Paint or something. You can just use it to like make different shapes and stuff, as well as like shade and color stuff in. So Figlet fonts are the like next big thing that you might have seen a lot of. They've been around since the early 90s. There's a lot of different fonts, and you can modify them and create your own. And I really like creating Figlet fonts, though I haven't released too many of them. But they're a lot of fun to just like generate. This padorjk.com, like the ASCII art generator, can do Figlet fonts in the browser. And there's also a really handy Figlet editor that I use a lot for laying out Figlet fonts. And my friend Zero as well has his own Figlet font repository, which you can see here. There's a ton of different just random fonts that you can use in the terminal. Here's some examples of designs of some fonts I did recently. One of the top one is based on Link's Awakening Zelda font that I was working on. And then another one is based on this N64 like BIOS font that my friend found. So if you look at here, there's like the layout of how like the Figlet font files are actually done. So if you want to create your own, there's a bunch of stuff that you kind of need to know, keep in mind, but it's really important to just kind of experiment too. The most important thing is to know your medium and its limitations and the features. So if you want to do something on like the terminal or the web or social media, whatever, there's limitations all over the place for those, and you have to kind of just keep in mind how people are going to see them, or how you're going to transport them and how people are going to view them. So 80 chars is like the standard for terminal things, just because that's just been the standard forever. I tend to stick to 80 characters in terminal stuff just because I like to use things on random small computers too. And so if you have like perfectly spaced art that's 80 by 24, it can look really nice in like a small screen. The widths are standard for standard there's like standard widths for sites like Twitter. Like so, like if you view something in the mobile app versus viewing it in the web app, things might look differently or shift, and it takes a bit of experimentation. There's also character limits too, like 280 characters for Twitter, 2,000 for Discord, 4,000 for Slack. So those are all like things to just keep in mind when you're making something. Knowing your char sets, like if you can only use ASCII, then you have to kind of stick within those bounds. Otherwise, you might get some weird errors, or you might be using some encoding that has different char character sets in there as well. But those are all like just super important to keep in mind. A lot of the times people are using UTF-8 now, which is pretty cool because it's kind of standardized, but you might find that there are cool characters that you can't use in UTF-8 and vice versa. And knowing your fonts is also really important too. I have some suggestions later on. So here's an example, and actually you guys can use this too. My website, no.lol or n0.lol/t/Slack emoji converter. I redid the font for this tool. Somebody had written a tool and I had changed the font so it was a bit smaller. But this is for making Slack emoji blocks. So we have this thing that says like stonks that's written in like Bitcoin, or rip to prod with that little rip gifs. Stuff like that though is like a perfectly valid ASCII art. The other things you need to know too, so beyond that kind of stuff, is if you're doing something in the terminal or doing something for it's going to be like in source code or something, is to know like your lines and blocks. So there's like box drawing characters and block elements. That there's a really good Wikipedia page that I always reference for these things. Knowing your basic shapes is really good too, like knowing how to make a square or a plus or a triangle, or this shading over here is really just useful to play around with. But super important is to know your ANSI escape codes to actually color stuff in. So you can add a lot of flair to your own source code and other terminal applications with ANSI or the ANSI codes here. If you're going to do something on a web page, it's really simple to set up like a text art on the web. So there's fonts like Unsky, Topaz Plus. There's other really cool fonts that are here at int10h.org for old, interesting monospaced fonts. Also, you can feel free to steal any CSS from null.lol or thugcrowd.com, because I did all the ANSI art there, or most of it on Thugcrowd. And you can feel free to use that if you want to put this kind of stuff on your own website. There's also something to be aware of too, just something I was dealing with the other day, is subpixel blur in CSS for some bitmap fonts and other like old school fonts. They're like specifically designed to be a very, very like specific pixel range. And so sometimes you try to like center it or move it weird, your browser will start to like make it look really blurry. So here's some examples of some web page stuff I've done. There's tons of different weird styles. All this stuff is done with CSS. I used to do the Thugcrowd show notes. So I would just make stuff like this every week and just kind of experiment with things. This is how I really realistically learn how to do most of the stuff, is just by having an application for it. But if you have like tools and things you want to add, your own art to, this is like a really, you have to have like a good reason, I guess, to get into it. So yeah, there's a lot of different styles I used here as well. You can see all of those on thugcrowd.com/notes. But yeah, so this is a lot of stuff that I've done. I've also been asked to do layouts for other websites as well, and zines. But I like using web pages because you can experiment with like different colors and effects. Like I only really use CSS, but you're able to use like CSS to do weird stuff like this the glowing pink cursive like sleazy Miami Thugcrowd logo. That one is done with just CSS, like WebKit basic stuff. There's also like different like color gradients and stuff that you can implement with CSS too, that you can't really do with ANSI art as much. So I typically prefer to do it like this, but you might be having different applications for it. It's not really easy to transport stuff from the web to ANSI, but you can use ANSI to HTML generators to create HTML pages out of ANSI, which is cool. So yeah, on the terminal itself, you can use just an ANSI file, like Moebius and PabloJaw will generate them. They're like binary file formats, but you can also do stuff like having a script to generate it at runtime. And so I like to do that. That can be fun for different reasons, but it depends on your application really. I also really like to add ASCII art to comments or spice up my source code. And you can also embed stuff so it can only be viewed by certain tools. So I've done documentation and stuff too. Like here's the big one in the top right is like the Python 3 PyC format. And it's really cool to use like ANSI escape codes and stuff like that to color in documentation, because it can make normally really boring looking blobs of hex look really cool with and readable with all these colors and layouts and things. But I've also just colored in randomly too, like write-ups and things as well, just so you can easily see stuff. Because if you're working with like big blobs of binary data and stuff like that, you want to color it in and make it look nice. And then you can use curl to directly transmit ANSI and put it into terminal stuff. You can also use, like, this is an example like raw escape, so you can use in your file, so you can even color within your source code, and it'll also render the same if you just run the script as well. But there's a lot of really cool uses for it. And yeah, here's some more examples of just terminal art. So you may have seen my inhale.py with the animated Kirby mouth by using the blink. There's a blink option for text in ANSI. And so the mouth blinks basically, and it seems to open and close. There's some other just random layout stuff that I've done over the years. This one was pretty cool too. This is just a script, as I was saying before, to generate stuff. So this is this is a little bit overkill, but this is a Tentamon from Digimon that's been drawn, and then it has this crazy script, this Python script that actually runs and generates it, which is a lot of fun. And then the final thing that I had said too was making your source code look really crazy. So there's a lot of languages you can do this with, and there's different, like the IOC CCC, or the International Obfuscated C Code Contest, is like known for really crazy art like this. But there's a lot of ways you can do it with stuff that isn't C. There's a lot of weird stuff, like with Python, you can append strings together like that without a plus, but then you can use that to make eyes or like mouths or whatever in like a block of a payload like that. And then you can use this to basically, like, the top left one was a joke, really. It was the most complicated hello world I could think of. But then there's also stuff like this with this different variables and in arrays. You can make like keys or skulls. You can also I like to put stuff in like embed things in the source code too. Just random comments. So if you've ever seen a page that were made, definitely check the source, because I always put like random YouTube links or drawings in there. Also really fun too is to make stuff so you can only see it in certain tools. So right here, this is things as Mafia. This originally said hex dump Mafia or something like that. But this was embedded inside of a binary. And so you wouldn't be able to normally see this in a text editor if you opened it up. But if you open it up in a hex editor, then you'd be able to see that it spells out this, and it's spaced to 16 basically. One of my favorite ones I did recently was this PCAP scroller. And so it sends basically a message that scrolls, and it says like, you're reading PCAPs, I'm reading your emails, we're not the same, but it scrolls it in that where that little O is in the hex dump of Wireshark, and it's perfectly spaced. That kind of stuff is always fun too, just for trolling and things. And so yeah, the last thing is some editors like Moebius can export your works to an image file. Other times you need to take screenshots. Sometimes for some reason, ASCII art can be rendered really weird. Like if you look at like here, if you see like the screenshot with this wasn't the best screenshot in the world, but is a screenshot of Kirby. It has lines in it. There's other times other fonts and configurations you can use that can get rid of those. Same with the blocks that are sometimes in some of the bigger ANSI art stuff that you might do on a web page. But yeah, you kind of want to like figure out what the best medium is to do your images. Moebius takes care of it for you, but other times when you take screenshots, you have to like have that in mind. And so with that, I think I'm done.
All right, that was great. I don't see a whole lot of questions in the chat, but it looks like people are super excited about both of the things that you talked about, especially the ASCII art stuff, which is super fun. And I'm going to exploit the Slack one all the time in my work Slack. So yeah, that's super cool. And if anyone else comes up with any questions, looks like we may have one question, but we're trying to track that one down. Yeah, if anyone else has any questions, let us know in the chat. All right, let's see. There's the link. Can you elaborate on how to go about analyzing and or interacting with malicious binaries that does C2 over a non-standard protocol using a malicious DLL? For example, how do you go about analyzing the switch tables, for example, in the disassembled DLL code that represent various switch cases based on the specific bytes received?
All right, so that's a really, really good question. And this is, so I had written this talk and I was like, this is not going to fit into 20 minutes because there's way too much that I want to do. So again, if you guys are interested in that specific topic, I will do a presentation. I might just do like a Twitch stream or something where people can ask me anything, or I might do a private Zoom call. But so for malware specifically, if you have a switch table, things like that, there are definitely paradigms that you can recognize when you're doing analyzing, like basically comparing values is like a big thing that you'll see within malware itself. So like compare EAX to like some other value like 1 or 2 or whatever, and then jump to somewhere else. So you can see those things. You can, you kind of have to look at, if you're actually analyzing the malware, look at how it's iterating over the buffer of data that it received, right? So you want to see like wherever the receive from buffer is in memory or on the stack or wherever, you want to see where that is, and then you want to just watch it iterate over the packet, because it's going to have to compare to stuff in a jump table. There might be some other obfuscation, but in a classical form, you'll see it like that, and it'll jump to like another function. And then you can map out and say, okay, if byte 12 is 0x15, then it jumps to this address. And you can map that stuff out with a table. But it's really important though to find the exact place where the buffer goes into the binary, because there might be other transformations that are done too, like it might decrypt it with a XOR key or some other key. And you can just, looking at that communication is really useful to see how it's actually processed and handled. Looking at it from a forward perspective of how it's created, sometimes that can be really crazy. And so it's usually, I like to look at how it's decoded rather than it's encoded, just because it gives a more straightforward way of the easiest path to get the data. But yeah, you can usually just take whatever that buffer is and compare it to what you see on the wire too, and see how that changes over in memory.
All right, super cool. I have no idea what you were actually talking about, but I'm sure somebody does. So yeah, that was great.